Night here.
Hi.
My name is Ismaldo, and this are my partners Ryan, Raven, and Rebecca. And we're going to talk about exoplanets. We're going to discuss what are exoplanets, where are they, how we find them, how many there are, why should we invest our money, and all that interesting stuff. So we should get started.
Okay. My name is Ryan again. Exoplanet, also known, a name is extrasolar planet. It's basically a planet that revolves around another star outside of our solar system. There's about 842 to 843, and still counting. Every day there's accumulating. They started discovering them in 1992. Approximately 50% of every sun-like star has a planet to it. And most of them are gas giants, just like Jupiter and Neptune, which are two planets in our solar system. But some of them are terrestrial, which are Earth-like planets. A habitable zone basically is when liquid is from freezing to boiling. It's when liquid is in that range. And planets are, it's considered the habitable zone. But it doesn't necessarily mean that life exists on those planets. For example, Mars is in our habitable zone, but no life exists there. There's 54 candidates as of right now that are in a habitable zone, but there is no way to confirm whether or not they're exactly there. There's only one planet so far that is confirmed to be in a habitable zone other than Earth, and that's Kepler 22b, which will explain some more details about that planet later on in the slides. Here's a graph just showing basically this is another star, and two planets revolving around that star. In the green area is the habitable zone, so this planet is within that, but this one isn't. And this is showing our solar system, where Mercury, Venus aren't in the habitable zone, where Earth and Mars is right on the cusp. Here we're just comparing different planets, gas giants, like I mentioned before, like Jupiter, Neptune, and terrestrial, which is Earth-like. Most of the time, they're near the star, and they're smaller. They have iron solid cores, and they have heavier elements, making it different from gas giants, which are primarily hydrogen or helium. The gas giants have solid cores, but they're not solid on the surface. There's nothing to basically stand on, so you can't go and stand on Jupiter. It's all gas. Most of exosolar planets are gaseous. They have cold temperatures, and they're the most common.
So, now that we know what are exoplanets, how do we find them? Well, astronomers today use numerous methods to find them. I want to talk to you about the top 3 ones, the most commonly used ones. The first one is radial velocity. Radial velocity, basically, what astronomers do is look at the star's spectrum. So we look at the spectrum and see if there's a Doppler shift in the spectrum. So if it's a planet orbiting the star, as the planet goes around the star, the gravitational influence will cause a pull on the star. And when we see the star move away from us, the light curve will move towards the red side of the spectrum. And when the star moves closer to us, the light curve will move to the blue side of the spectrum. So as we see the dashed line moving to the red side, and the wheel moving to the blue side. So with this we can tell if there's a wobble in the star, then there must be a planet orbiting that star. Another method is the astrometric method, which is the oldest one. Astronomers, this is the first method since the 19th century that they've been watching over stars. And it's similar to the radial velocity method, but it precisely measures the wobble of the star. So like I said, when the planet orbits the star, making it to move from the center mass, it's going to switch to the movement of the stars. And we measure with a space telescope because the atmosphere on Earth will not allow us to do this from the floor. So we got to use the Hubble Space Telescope and such other telescope to help us measure this precise measurement. Third, we have the transit method, which is my favorite. It's the most promising one also. Basically, we observe the brightness of a star. So we observe the brightness of a star over a period of time and see how it changes. So if there's a planet orbiting that star, when it's transit, meaning the planet goes in front of the star, it will cause a drop in the brightness. So as we see here, this is the brightness of the star. And as a planet goes in front of the star, you'll see a drop in brightness. This in the case, it's a transit. How deep the drop is how big the planet is. Basically, it's like an eclipse, like the moon going in front of the sun, or Mercury always going in front of the sun, or Venus for us. And we can detect the size of the planet with this because of the drop of it. And as we see, phase 2 is moving in, phase 3 is in the middle, it's the bottom drop. For this is very difficult because we got to look at the star edge on. So we have to see the planet edge on in order to see it. If it's not edge on, we can't detect the transit. And it doesn't have to be right in the middle. It can be anywhere on top, the edge, a little bit. As long as it's a transit, we can detect it. Well, Kepler's mission. Kepler's mission is to find Earth-like planets in the habitable zone. So, this is a telescope. It's a photometer. It has a wide field of view. It's going over 150,000 stars, and it's looking. As we can see, this is the field of view right here, and it's recording all this data, and it's sending back about 6 million pixels per every half an hour. And what we're doing is astronomers are recording all this data and step by step going over it to see if there's a transit in the stars. It's pretty much mission is still going on. It was supposed to be only 3 years, but it was extended to go 8 years. It's a very expensive mission, and we detected over 800 exoplanets. So it's very promising. We're still working on it.
Okay, hi, I'm Reagan. We decided to look up 3 different planets just to give you an example of the different planets that were found using the Kepler telescope. The first planet is Willis 581b. It is 20.3 light years away. Just in case anybody doesn't know what a light year is how far light travels in a year. Just to give you some perspective, the sun is only 8 light minutes away. So that basically means if you were driving to the sun in your car, going 60 miles an hour, it would take you 180 years just to get there. So our fastest space shuttle goes 5 miles per second. That sounds pretty fast, right? So that's 18,000 miles per hour. Light travels 186,000 miles per second. That's 37,000 times faster than our fastest space shuttle. So if we sent a shuttle just to this planet alone, well, not to this planet, but just to send it a light year, it would take 37,000 years. So anyone who thinks they've been visited by aliens, I suggest you thinking that. But this planet just happens to be 20 light years away. So if you can imagine how long it takes for to get to 1 light year, imagine how long it would take to get to this planet alone. And it takes 66 days to orbit its host star. It is 6.4 times bigger than our planet Earth. It was discovered in the year 2000, and it's in the constellation Libra. We sent a radio signal in 2008 because we discovered it was in the habitable zone. And we're going to get a signal back if there's life that can detect radio signals and send one back 2029. The next planet is Kepler 22b. It is 587 light years. We'll never be visiting there. It takes 290 days to orbit. It is 2.4 times larger than Earth. It is also in the habitable zone. It was discovered in 2011 and is in the constellation Cygnus. The last planet is Kepler 47c. It is 4,900 light years from Earth. I don't really have to comment on that. It is located in the constellation Cygnus again, the outermost planet in a binary star system. That basically means, well, this is the planet. This is a picture of the planet in the background, and it's orbiting two different stars. And this was the first planet, I do believe, that was found orbiting two stars. And we also actually found another planet that is orbiting four stars. So it's pretty amazing stuff that we're doing here. It's a gaseous planet that is slightly larger than Neptune. Its orbit is 303 days. It's located in the habitable zone as well. But I do believe it's a gas planet, which means there's most likely no human life, at least, on the planet. Probably no life at all. And its atmosphere basically consists of water vapor.
So a lot of you may be wondering, why are we spending money on doing this? And despite what most people think, it's actually not for finding life on other planets. It's about trying to figure out how our solar system started, and how the universe was created, and to understand other solar systems. That's what we're trying to figure out. So instead of like, oh, maybe there's aliens out there, which there may be, because I mean, you think about it, there's so much possibility. But like, it's not like we're going to be able to visit that. So this is much more important when you think about it.
Well, that's pretty much what we have for tonight. For anyone who's interested in an app, check out Exoplanet. It's a very cool app. iPhones, it's iPod, iPad. It's free, and it tells you, it updates every time there's a new exoplanet. It tells you how far it is, all the information you need to know, pictures, and all that. Also, planet hunters. They have one confirmed exoplanet, and basically they gather all the data that we have, and they see, they're using the transit method to find if there's a drop on the, like I said before, it's a drop in the brightness, and it detects exoplanets, and anybody can do it. They teach you step by step how to do it, and like I said, there's one. So people like you guys found one exoplanet, and they got the names on the paper. The article that was written has all the names, like about 12 or 60 of them, that collaborated with them. So check it out. That's all.
Anybody have any questions for them? Anybody have any questions?
No questions?
Oh, I had one. Oh, yeah. Who and how do they decipher the names of the exoplanets?
Basically,
That's my sister.
Oh, whatever. I don't know.
basically, it's the group gather together and figure, and they will go through the data. It's not only one person, it's just multiple people go through the data to confirm that there's an exoplanet.
Right.
To confirm that, depending on how they find it. Like if the Kepler's telescope, then they'll name it Kepler after the telescope, and the numbers of it, 10B, 10A, on the galaxy that it's in, on the constellation, based on like all that type of stuff.
Oh.
Anything else?
Oh. I mean, I can go all night. Great. I'm done. I got it.
Could you show them, like, just one example of how would a planet orbit 2 or 3 stars at once? How's that happen?
Well, it could be like those stars
Planet
are